Before you start the next lesson, I've got this warm-up question. It deals with trigonometry, our old friend. So you need to recall what you learned in the trigonometry unit, solve this problem, and the reason I'm bringing this up again is because we're going to use trigonometry when dealing with vectors. So pause the video, see if you can figure out the length of this side in the triangle and this angle here using the given information. Notice these lines are parallel. You can use that in this question. Okay, so pause the video, try it, and check back in when you're done. Okay, so first thing I did was I noticed there's a Z pattern here. So if you have two parallel lines with a transversal, that Z pattern or alternate angles are the same. So if that's 35 degrees there, this is 35 degrees inside the triangle. Now if I just look at my triangle, I know two sides and the angle in between them, so I can figure out the third side using the cosine law. So use the formula for cosine law, plug in my numbers, solve, don't forget to take the square root. To get x, I got 2.3 meters. So now that I know this is 2.3 meters, I know a side length and the angle that it's opposite to, so I can use sine law to figure out my missing angle. So 4 over sine theta equals x over sine 35. Okay, cross multiply, 4 times sine 35 divided by 2.3 equals sine theta. Take the inverse sine to get the angle, which was about 86 degrees. Okay, so hopefully you were able to do that. If not, maybe just go back to the trigonometry unit and do some review, watch a couple videos just to get your mind back in that before we get into this lesson. So this lesson is talking about geometric vectors. Okay, so we're still talking about vectors, magnitude and direction, but this time we're going to represent those vectors geometrically, so by drawing, using shapes, hence the trigonometry. So we're going to represent and draw vectors graphically or geometrically by drawing, and we're going to perform the operation required to determine the magnitude and direction of the resultant vector. So I'm going to talk about what a resultant vector is and how you figure out what it is using our understanding of geometry and trigonometry. But first, some terminology. So the idea here is that vectors can be combined. So if I have vector A and vector B, and I add them together, the resultant vector is what I get. Okay, so when I say resultant vector, it's what do you get after you add those vectors together. Okay, so if I go from add vector A and vector B, you start and finish, and you just take the shortest distance from start to finish. I guess that's how I'm going to word it. Okay, so this resultant vector is overall where you start and where you end when you add A and B together. Okay, so this idea is going to come into play as we work through this. Now the main idea here is the triangle law of vector addition. Okay, so when you add or subtract two vectors, draw the two vectors head to tail. Okay, so remember the tail is the point, the head is the arrow. So if I have one vector plus another vector, I'm going to draw them, well, the head of this one against the tail of the next one, and the resultant vector is going to be from the tail of the first one to the head of the second one. So this is correct. This is not what you want to do. So here I have tail to head, tail, head. I have the two heads touching. That is not how you add vectors, okay? So there's a correct way and there's an incorrect way. Make sure you're doing the correct way when you add your vectors together. Now, this resultant vector, we're going to use trigonometry, sine law and cosine law, to figure them out. Here's my first example. If the magnitude of U is 10 units, the magnitude of V is 5 units, and the angle between the two vectors is 30 degrees when placed tail to tail, determine the resultant. So here's a diagram of what the given information is in the question. It says that U is the longer vector, V is the shorter vector. There's an angle of 30 degrees between them when they're tail to tail. Okay, so this is what's given. But I want to know the resultant vector. So that means I have to add these vectors together. Don't start with this diagram because these are tail to tail. We need tail to head. So I'm going to take vector V and I'm going to slide it over so that the tail is over here. Okay, so when I take vector V and I move it over so that it's the head of U is against the tail of V, it looks like this. Okay, so I've still got that 30-degree angle, but just be careful where you put it because that 30-degree angle is from the horizontal up to V. So from the horizontal up to V is 30 degrees. This is the diagram I want to use to find my resultant. Okay, so the resultant vector, well, if I'm adding U and V, well, I'm starting at the start of U and I'm ending at the end of V. So this is what it looks like. I'm going to use R to be the resultant of U plus V. Okay, so vector R is this red arrow here. Okay, so that's the vector that I want to figure out. So in order to determine this resultant vector, I need both a magnitude and a direction. So the direction, I have to figure out this angle right in here. So we're going to use trigonometry to figure out the magnitude and the direction for this resultant vector. Okay, we got to do some prep work here. We have a triangle. We need to label lengths of these two sides. We also need to figure out this angle in here. It's very easy to do. First off, the lengths are given in the question. So the magnitude of U is 10 units, the magnitude of V is 5 units. And this angle in here, well, it's on a straight line. This is 30 degrees. A straight line is 180. So 180 minus 30, well, that's 150 degrees. So I have a 150-degree angle in there. So my first step is going to be to find the length of this side, which is the magnitude of R. Okay, now look at the triangle. I know two sides and the angle in between them, so I can use cosine law, just like we did in the warm-up. So if I use the cosine law, well, R is the side that I want to find. U and V are the other two sides. Now I've just used the letter A to represent the angle in between U and V. Okay, so I'm just using a generic label here so that I can build a formula that will work every time to find the resultant between two vectors. So to find the magnitude of the resultant vector, I just have to take the square root of that. Okay, so this is the formula. This is the formula that will work every time you're asked to find the resultant between two vectors. So vector U and vector V, magnitudes, okay? And then A, it represents the angle in between angles U and V. When they're drawn properly, of course, from head to tail. All right, so back to this question, we can just plug in our values for the magnitude of U and the magnitude of V, and the angle in between those is 150, and then we can use our calculator to solve. So when I do that, I get 14.5 units as the magnitude for the resultant vector. Okay, so I've got the magnitude of the vector, that's half the battle. The next part is direction, so I need to find this angle, which I've labeled theta, and then once I have that angle, I can say what the direction of the vector is. So if I look at my triangle, I now know an angle and the length of its opposite side, so I can use sine law to find out my missing angle, just like in the warm-up. So just using my generic labels here with sine law, so the magnitude of R over the sine of the angle between U and V is equal to the magnitude of V over the sine of this angle theta that I'm looking for to get the direction of my resultant. So that's sine law right there. And if I want to solve for sine theta, remember cross multiply and divide. So magnitude of V times sine A divided by magnitude of R. And then I have to take the inverse sine of that, of course. So when I solve for theta, take the inverse sine of magnitude of v times sine A divided by magnitude of r. That formula will always work. Keeping in mind that angle A is the angle between u and v when they're head to tail. Okay, so I'm just going to use this formula, plug in my numbers for this triangle, and I'm going to solve for the angle. And when I do that, I end up getting about 9.9 degrees, or about 10 degrees. Okay, so I have the magnitude of my resultant vector and this angle to indicate direction, but how do I write that? Well, I'll show you. Okay, so r is 14.5 units, that's the magnitude. And then direction, we always put in square brackets. Okay, so if I look at r, I'm going right, then up a certain amount. So I'm going right, and then up 9.9 degrees, because that's the angle in there. So that's how I write it. Right, and then 9.9 degrees up. Now, if we're talking about compass rose, so like north, south, east, west, if north is at the top, east would be off to the right, so I'd be going east 9.9 degrees north. So I would write it like this. Okay, so when you write out a vector, you have to include the magnitude, and then in square brackets, we put the direction. Okay, here's my second example. Determine the resultant. Okay, so here I've got vector u, 4 units, 50 degrees down from the right. Vector v is 6 units, right up 20 degrees. Okay, so I want the resultant. That means I need to add u and v together. And remember, when I add them together, I have to add them head to tail. Now to start things off, I'm going to just draw a diagram here. I'll explain what I did. So I've got vector u, and then I have vector v, and I'm putting them together, head of u at the tail of v. Okay, so this is u, this is v, put them together, head to tail. Okay, now I noticed that I can make a Z pattern here. So alternate angles, this is 50 degrees down here, this is 50 degrees here. Okay, so that's this part. Now I have 20 degrees here, which is here. All right, now my resultant is from here to here, the red arrow. All right, I know this horizontal line is a straight line, so total I have 180 degrees here. Now this side's 50, this side's 20, so total that's 70. So 180 minus 70 is 110 degrees. So I have a 110 degree angle in here. Okay, my next step, I have u, I have v, I have the angle in between u and v. So I'm just going to use the formulas I figured out in the previous example to find the magnitude of r and its direction. So here's my formula that I derived in the previous example. Plug in my numbers, use my calculator to solve. So I get the magnitude of r is 8.3 units. Now theta will be the angle in here across from vector v. And this was the formula that I derived in the previous example. So I'm just going to plug in my numbers and use my calculator to solve. And you'll see I get an angle of 43 degrees in here. Now, I'm going to have to do a little bit of extra work this time because notice this angle is not the angle from the horizontal down. Okay, so if we want to know the direction of r, we need to go, okay, I'm going east, what angle south? Okay, so I need to know an angle in here. So we need to do a little more extra work. I'm going to start by zooming in to this area on the diagram so I can figure that out. So I'm going to start with vector u. Okay, here's vector u. It's 50 degrees down from the horizontal. Okay, now I also have vector r 43 degrees away from u. So that's here. All right, so from the horizontal down to u, it's 50 degrees. From u to r is 43 degrees. So the question is, what's this angle in here? Well, if the total angle is 50 degrees, then I just have to take away the 43, and I'm left with 7 degrees. Okay, so now I know the direction that my resultant vector is pointing. So I'm going to talk in terms of north, south, east, west. So my resultant vector is going east and then 7 degrees towards the south. So I'm going to write that as r is 8.3 units east, 7 degrees south. Okay, here's my last example. Determine the resultant of 3u minus 2v plus w. So here I have u, v, and w shown on the grid. Okay, so for magnitude, I'm just going to count the squares on the grid. Okay, and direction I can see, well, this is right, this is down, and this is left a certain amount up. Okay, so I'm just going to add 3u, so I'm going to take u and have 3 of them. I'm going to subtract 2v, okay? So if I'm subtracting, that means I'm going in the opposite direction. So if v is 2 units down, then minus 2v will be 4 units up. Okay, and then I'm going to add w, so just keep it the same. So my resultant is, when I start here, I end here. So that red line is my resultant. So now I just have to figure out magnitude and direction. Now I'm imagining a right triangle here. I counted the squares, 6 units to the right, 6 units up. Theta is my angle here. So to find the magnitude of r, I can simply use Pythagorean theorem here. Easy. So the magnitude of r squared is equal to 6 squared plus 6 squared. So to find the magnitude of r, it's the square root of that, and I get my answer. The magnitude of r is 8.5 units, and that seems to match what I have on here. Okay, now I need the direction. Well, this is a right triangle. I have opposite and adjacent, so I can use tangent to find my angle. So tangent of my angle is opposite over adjacent, so 6 over 6. Take the inverse tan of that, it ends up being 45 degrees. So r is 8.5 units east, 45 degrees north. And that's it for this lesson. So just remember, when you're dealing with vectors in a geometric way, you got to draw the diagram and make sure you use your trigonometry correctly to figure out magnitude and direction for your resultant vector. Try the practice questions now, and if you get stuck or have questions, let me know so I can do my best to help.